My MATLAB is finally running. So can you, YouTube officer, can you check that we are good? Okay, very good. Also, the overhead projector wanted to go to sleep, so we'll see when I put it back on. System, okay, should be back on now. Not quite yet, but soon it will be. Can you checking how is my voice? At least based on that, what I can see here, it should be fine. Should be very good. Clear and understandable.
Yeah.
Clear and.
But the camera is
still frozen.
Yeah, the camera is frozen, and there's the same picture where you can see 1,000 times.
Yeah. That's the idea. But I have to share my monitor, so. But I don't get it. Like why why this picture is still not yet on. I guess that I now have to change this camera and then back to this camera. It's on. Okay, good. So what's still missing is okay, it should be 3 seconds and then is on. Not yet on. Yes, it is on. Okay, so I'm gonna put this away and then it's looking more clear like this. Okay, so what I have, I have software exactly the one that I introduced you last week, but this time it's describing this system with the two moving bodies, and I'm, just shortly, what I have here is a number of maximum iteration in a position level. This is my tolerance. It could be something else if you're not comfortable with that number. And then I have here initial lengths of two bodies, body A and body B, initial angle, initial coordinates for my generalized coordinates, so where is the Rx of first body, Rx of the second body, where they are located, angle, theta, and so on. And then these are the vectors where I'm starting the running the system. Then, I'm going to run the system on all the way to 7 seconds, and then I will stop. And then this is my constraint equations. It's exactly the one you can see from my example. Now, of course, the coordinates are, coordinates are from the vector q0, and the q0 is this vector here. But I'm simply substituting the initial values to my vector of generalized coordinates. And once I'm done with that, then I'm good to go and compute my constraint equations and Jacobian matrix. And then I'm ready to compute my Newton difference. And this is where I'm updating my Newton difference. And I will do that until I reach the, the numbers that are small enough. That's just the programming. This is an updating procedure. And here's my velocity equations is substitution, and acceleration is substitution as well. So I'm ready to run this thing. So now it is computing. Is the programming and everything is really lousy. But the idea is to make this as simple as possible. So soon I'm ready to animate the system. You guys ready? Remember the last time it was simply great. This time it's going to be more than that. Okay? Silence, please. Silence. We have to focus on this. Isn't this art? It is. Unbelievable stuff. So we solved the kinematics. So this is what you can follow, but solve the kinematics for any mechanical system. Of course, the limitation we have in this course is that we're dealing with the planar system, two-dimensional system. In three-dimensional, things are a little more complicated. But in 2D, now you know how to make it happen. So that's how it goes. And now I have here, different solutions: angular acceleration of body 1, angular acceleration, angular velocity of body 1, so on, orientation, local coordinate system, so on and so on. I can plot whatever I want from the system because I know all the coordinates in position, velocity, and an acceleration level. That's how it goes. Now, let's put this off, and then I need to close this one here, and then put where's my this guy here? Okay, so I guess that I need to use a QR code again. No, not willing to cooperate. So what's the problem today? I think it is this. Oh yeah, now I know what's the problem. The problem is this cable, because there's a cable connection. So this is not the Wi-Fi connection. So now it should be all right. Let me scan the QR code one more time. Not yet. What's up with this? Connection is all right, but I think it is a VPN that destroys this time. So let me check how is a VPN disconnecting. Interesting. No, still not. What could be a possible problem then? Do you know? Because I don't know. Okay, let's see. Quite a bit of technical difficulties today. So it's still disconnecting. So it's disconnecting, so maybe you need to be completely disconnected before I can start using this. The play is still running, still running. QR code. No, it's successfully. Okay. Look, maybe I thought that you can go back home, but no, not yet. You know, we have still some things to discuss. Okay, so then let's check how is OBS. OBS is like this, so I don't want to use this. Okay. Be back on, and it's all good, isn't it not? It's all good. All right. Now this is what we discussed before the break. So we discussed that vector of generalized coordinate, which is denoted as a Q, and then this vector of generalized coordinates for one body that consists of three components because of the three generalized coordinates. And these three components are mentioned here. So I have vector F, force vector, that is applying to generalized coordinate Rx and Ry. And then I have this moment that is depending on the moment arm and the body orientation. And the moment arm comes from the vector U bar. So if the force is applying in the center of the body reference coordinate system, excuse me, in the origin of the body reference coordinate system, vector U bar will be, in that particular case, what's going to be the vector U bar? 0, which deletes this component. So then there is no moment or no component affecting the angle theta. So there will be just the force component, and then the third component will be equal to 0. That's how it's going to be. Okay, so now my first question is this. Physical interpretation of the matrix. Remember, this was a quite long time ago. We discussed about the matrix and physical interpretation of the matrix, but it was like half an hour ago. Now, online participants, you have this opportunity to go to check it out. How was the streaming or the recording? The recording is already available. Try to find that particular location in the recording when I keep on repeating the physical interpretation of that matrix. And now the choices, what I have here, the choices are, and this is not big enough. Let me use this one here. So the choices are that it defines the relationship between the global coordinates and constraints. Global coordinates and constraints. First option. It defines a relationship between the constraints and generalized coordinates. It defines a relationship between the global and generalized coordinates. Option C. Option D defines a relationship between external applied forces and constraints. It's a little difficult, I have to admit that, but this is clearly doable. It's doable. Because, remember the whole idea of all this. It was, the story about the virtual work and the virtual displacement. Why we do the virtual displacement? That matrix is exactly the reason we do the virtual displacement. So remember there was, two different stuff that have to be related. But what are those two things? Okay, now you need to be honest. Do you feel that this is a difficult question? Okay, at least Team German is completely confused. You're completely like, okay, what's going on? So I have no idea. I need to guess. So Team German, do you need help?
Yeah.
You need help. What about other? So what other teams we have here? So Team Russia. Team Russia is doing good. They look at them. They're showing off. They know the right answer. Team German is confused. What about what other teams we have? This is Team China. How is that Team China? Strong. Fine. You know what's the correct answer. What is this team back there? Algeria. You're doing good. What's the team in the middle? Where are you guys coming from? Different places. So it's not the one team. So it's a mixed team. Tanzania team. And I guess the team in the back is the strongest team. Finland. I always know that that's always team in the back. It never comes team in the front. Okay? Okay, so you all need a little bit of help. Not anymore. Okay, Team German is playing dirt. So they're using tricks that are not allowed. Everything is allowed here. That, the question regarding the midterm exam. Again, you have a full week time to make 2 attempts. So it will be online exam, and you can use any material you want, except your mom is not allowed, and your fellow students are not allowed. But other than that, father too, not allowed. Father, yeah, not allowed. But other than that, you can use all the recordings, all the PowerPoints, lecture notes, Google, whatever you want. Google is with you. Symbolic math tool. Recommended, by the way, because I'm asking mathematical questions. I'm asking, for example, you to derive Jacobian matrix. So it would make sense you to make some kind of template that helps you to compute the Jacobian matrix, because that's what's going to happen. So you need to practice yourself, because the problem in the online exam is that if you don't get the correct answer, you'll not get any points at all. That is a very black and white, which is a little bit of problem of that exam. But other than that, it's quite great. In 2 attempts. Look at you, you're looking really serious. Whenever I mention a midterm exam, you're becoming like completely white and shaking and everything. And you should, because it's extremely difficult. It's not that difficult. You can easily score very high in a midterm exam. But back to this. So what is not this, but this. Okay, so we have 63 students. I believe that's all today, because Last time it was 60 something students. So you guys all done? Online participants, are you all done? I guess that no comments, so I'm good to check it out. Okay, a few more are still entering the answer. So now you need to cast your answer. This is not going to be 100% success rate. So is that an echo? Okay, what's going to be the success rate today? You're very good in this. So what's going to be the success rate? Yeah, you're always guessing correctly. 86, that's kind of high. 25, 75. Look at this. Woo! Awesome. Because this was a difficult question. And I tried to confuse you with the constraints. Remember a lot of discussion about the constraints in the past. This time, no constraints any longer. It's all about two coordinates. Two coordinates we're dealing with, global and generalized. All right? So 87% guess it right. Others, it went a little bit incorrectly. So it's not defining the relationship between the global coordinates and constraints. And is it defining the relationship between the constraints and generalized coordinates? And is not defining the relationship between the external applied forces and constraints. So C is the correct one. All right. So let's practice a little more. So now I have here a real problem. The real problem is a beam-like body, and here in my beam-like body there is a force that is applying in the center of mass. And now the center of the mass is the middle of the beam-like body, and the body coordinate system is located in one end of the beam-like body. Now my first question is that, when we're going to express this using generalized coordinates, there's going to be three components. Third, final component will be associated to angle theta. Is that going to be 0 or non-zero? Non-zero. Because force is not applying in the center, in the origin of the body reference coordinate system. It is applying in the center of mass of the system, but that's not where the body reference coordinate system is located. So this is to try to confuse you a little bit. Okay, so let's make it happen. The point where the force is applying is a point O. That's pretty much all we need to know. And we also need to know where the body reference coordinate system is located at. So it's one end of the beam-like body. So then we just compute where the force is applying, and then creating this mapping matrix. And with help of the mapping matrix, we can define the generalized externally applied forces for this system. Okay, you ready? So, this is the equation how it goes. So I have first defining where the point O is located, and this was made. This mapping matrix that is here was actually given to you earlier, and it was given to you in this format. So I have here identity matrix. This is a vector U bar that is only a little bit of different components. Others are very clear and straightforward. So once I take the vector U bar, which is the x-axis is pointing in this direction, so it's going to be L divided by 2 x direction, 0 in y direction. So when I substitute that information here, when I compare this one here, this is how the mapping matrix look like. I'm kind of cutting the corners here, so I'm not showing the details. But if you want to learn the details, check it out from the previous class. How was this rotation matrix differentiated with respect to angle theta? Okay, so now this is my mapping matrix. Now the mapping matrix is then multiplied with respect to force. And the force vector consists of two components. X component is equal to 0 because the gravity points us minus y direction. All right. How much is in a minus y direction? That's mass multiplied by gravity constant. Once you do the math, that's how it looked like. So force, look at these two first components. These are exactly the force components. I'm just transferring them to my generalized forces. Third component, this is, the force where the force is applying multiplied by level arm. And the level arm depends on the angle theta. That's how it goes. And this one is applying to theta coordinates. Okay, makes sense. How this would be different if I would change the body reference coordinate system such the way that it will be located here in the center of the mass. How that would change the game. Remember the final solution. Again, I'd like to apologize that this is very unclear writing. The 0 minus mass multiplied by gravity constant. The third component that is associated to angle theta, what that would be in this particular case. If the body reference coordinate system is located in such the way that the force is applying in the origin of the body reference coordinate system. Who was it? So it was a 0. 0. Okay? You got it? Clear. Why it's 0? Because no moment. Vector u bar is equal to 0. But yeah, you're right. Your explanation is better than mine. So I'm explaining that in a mathematical way, you using the physics. Okay. Would you like to come here? Okay. Here's my Inclass Quiz. Gravity force is applying in a body shown below. Vector of generalized externally applied forces is as. You will know the solution without doing any computing. And the choices are, like shown here. So it's 0 mass multiplied by gravity constant 0. 0 mass multiplied by gravity constant, and then this moment. And then the one that consists of two components, 0 mass multiplied by gravity constant, and the third one that consists of two components, 0, and then this very complicated one. One only is correct. But which one is correct? Next. Okay. You need to check it out, the slide, so I need to put the slide back on. So this one here. After this, I have just one example, and then we're good to go back home. Team German is still confused. Today is not their day. So they are like, oh no idea, absolutely no idea. I have to guess. No. Completely clear. You sure? Are you sure that there's no tricks? You want to rethinking your... No, you can. Sorry about that. Okay, let me tell you something. There's no tricks. There's no tricks. No tricks. There's no tricks. And why there's no tricks? Because I really would like to see the 100% here in the screen. When that happens, you need to take a... I need to take a selfie with 100%.
So we can take just a picture of you.
Well, but it's not the 100% success rate. I need that 100% success rate. With the numbers, such that there are, 60-something students, all these 60-something students they know what's the correct answer. It will. This time it will.
Well, I think this could be higher than the previous one.
But the previous one was a difficult one. Not. I'm thinking 100. Okay. So let's go and. So you know what's the correct one? I'm gonna check this one. Okay, it seems that we are a little bit of you need a little bit of thinking. So I'm gonna explain my next example. Excuse me, and then after that example, I will go and check it out how is the scoring. My next example is a triangular shaped body, and this triangular shaped body is, excuse me here. The triangular shaped body is this one here. The body reference coordinate system is located in one corner of the triangular shaped body. two forces applying in other two corners. And now, very important to understand that these forces are expressed in global coordinate system. And the forces are expressed by using these two numerical values. So even if the body orientation would be this, the forces are still pointing out their original direction because they are expressed in global coordinate system. And they are having constant values. So those are not variables, but they are constant values. Okay? Now, vector u-bars are given here. So let's compare how is a general vector of generalized externally applied forces of this example. So how it goes? It goes in such the way that I'm expressing these points where the force is applying. First I will get started from the point A, and I will, again, surprising enough, I will use this equation that you are very much used to deal with. All right? So first I'm expressing where the body reference coordinate system is located. Here I'm accounting the orientation of body reference coordinate system, and with help of vector u-bar I'm traveling to this point. Okay? Now this is my expression of point in global coordinates. This is r vector. Now I'm going to differentiate the r with respect to generalized coordinates. So what are the generalized coordinates in this case? Rx, Ry, and theta. One more apology about my writing today, it's very unclear. But you differentiate this one here first with respect to Rx, that's going to be 1. You differentiate the same equation with respect to Ry, 0. You differentiate this one with respect to angle theta, this is it. And then you do that for the second row, and that's the mapping matrix you can get as a result. Now I have the mapping, and then I can multiply the forces with the mapping, and this is how it reads. That's my final solution. For this one particular force, I will go on and take it out how is a point P, and following exactly the same procedure. So I'm first traveling the origin of the body reference coordinate system, I'm accounting the orientation, and now vector u-bar will be different. Vector u-bar is the one that is given here. I do the substitution. This is my x and y coordinates of the point. Now I differentiate that with respect to my generalized coordinates, and this is a mapping matrix I get. Now mapping multiplied by a force gives me the final solution associated to point P. Final step, simply summarizing these two forces and summing them up. And when I'm summing them up, this is how it looks. That's my first force, second force, and this is how the final solution look like. Now you can see that this component compensates itself if the angle is a 45 degrees as shown in a figure here, or 115 degrees. Okay, a little bit fast. And now is a moment of truth. Are you guys excited? Okay, so it's going to be 100% then. Now, okay, few students are giving up because now we only have 59 students. The first Inclass Quiz, I think it was 68 or something like that. 67. Okay, 60 students. Now we're going to count it. So in 5, 4, 3, 2, 1, or 2 more, and 100.
Yes, true.
Okay, so what went wrong then? Because okay.
Maybe they didn't see the slides as you.
So I don't think that's a reason, because if you're following the lectures using the online option, is all same. You can hear these explanations exactly same way.
System mistake.
System mistake, correct. So system have a problem. So okay, system have a problem. Obviously, major problem. This is it's too much to handle. Too much to handle.
Yes,
You know, even, you know, this overhead projector saying that this is not, you know, this is no good. Let's just go back home. Okay, so what do you say? Should we go back home then?
You think I'm nice?
Okay, let me try to see what's going to happen next. So what is the next slide? Okay, this is a little bit about the moment. And then we're ready to, okay, this is pretty much the end of the story. Because, you know, what happened